Hi to all. Today's topic is transformer. What is a transformer? A device used to change the smaller voltage to larger voltage and vice versa. That means this device can change the small voltage into large voltage into small voltage. This is a transformer. It can change the small voltage into large voltage into small voltage. If the transformer increases the voltage, that is called a step up transformer. If the transformer decreases the voltage, that is called a step down transformer. When the voltage increases, corresponding current will be decreases. Okay, you see here, if the input voltage, for example, input voltage is less than the output voltage, that means if output voltage is more than input voltage, that means voltage is increased but the corresponding current is decreases. That means it can change the low voltage to high voltage. At that moment current will be changes, high current to low current, right? You remember that simply. This is a device which can change the smaller voltage into larger voltage or larger to smaller. That is called as transformer. What it consists? Right? At many places we will use the transformer. If you want to use this transformer for the less voltage, if you want to generate only 12 volts or 10 volts, right? At that moment you can use the step down transformer. You want to convert the high voltage into low voltage. If you want to convert the low voltage into high voltage, you have to use the step up transformer. Okay, right. Let us go for the construction. This is the soft iron plates, rectangular plates, and then here this is the primary coil. It has the number of turns N1. Insulated copper wire wound at one side, at the one arm. At the other arm another wire is wound. At here input is given, at the here output is taken. N1, N2 are the number of turns in the primary and secondary coil. I1 is the current in the primary coil. This is the primary coil. This is the secondary coil. V1 is the input voltage in the primary coil. Input voltage are the voltage applied to the primary coil. And V2 is the output voltage or the voltage taken out from the secondary coil. Okay, right. And then let us see some principle at here. It works based on mutual induction. But means there is no direct connection between the primary coil and the secondary coil. We are giving the input to the primary coil. This is insulated wire, and here we are connecting through the laminated plates, right? And this laminated means some coating is there, insulated. This is also insulated. That means there is no direct connection, but due to the mutual induction, this current will be induced. That means if you change the current, if you apply the AC to this, alternating current means its voltage will be changes. When current and voltage changes, then magnetic field generated by this primary coil changes, flux changes. That flux link with the secondary coil. When the flux link with the secondary coil changes, then EMF induces in the secondary coil. That means the mutual induction means induction of current in one coil due to change in current in another coil. When the current applied to the input primary coil, if it changes, if the current supplied to the primary coil changes, then the current induces in the secondary coil. When current changes in the primary coil, flux link with the primary coil and secondary coil also changes. When magnetic flux changes, then EMF and current induces in the secondary coil. That phenomena is called as mutual induction. Okay, it works with only AC because where the varying current, it can, when the current varies, AC means varying current. When current varies, field varies, flux varies. The change in flux only produces the current and EMF in the secondary coil. It cannot work with the DC because when you supply the constant current, then the field constant, flux constant, that constant flux link with the secondary coil. That constant flux cannot produce any current or EMF. That's why output voltage is 0. It cannot work with the DC. If you apply the DC input, then there is no output. That means output voltage is 0. It can be used to change the smaller voltage to larger voltage and vice versa. Okay, less voltage to more voltage or the more voltage to less voltage. Let us see some related to this one formula I am going to derive. Okay, it is very important topic. Transformer is very important topic. Let us see here. what we have to do it here? Then according to Faraday's law, we have to write induced EMF in primary coil, induced EMF in primary coil. Okay, induced EMF in primary coil or the input voltage. Actually induced EMF equal to input voltage. Okay, when it possible, if the resistance of the wire is negligible, then the induced EMF is equal to input voltage. Induced EMF equal to input voltage. Then what is this induced EMF formula according to Faraday's law? Right, that we know as induced EMF equal to minus n d phi by dt, right? Minus n d phi by dt, this formula you know. Then input voltage is V1, we write voltage equal to EMF, but the EMF is minus N1. Induced EMF in the primary coil, the number of turns is N1, the rate of change of magnetic flux is d phi by dt. This is equation 1. And the induced EMF in the secondary coil, induced EMF in secondary coil. In the secondary coil, how much EMF induces? In secondary coil, that is equal to output voltage. That is equal to output voltage or output voltage. What is output voltage? That is V2. Then V2 we write as minus N2 d phi by dt. The rate of change of flux is same. How much flux changes in the primary coil, that will link with the secondary coil. We are considering that one. Okay, right. This is again we have to use the Faraday's law, induced EMF equal to minus n d phi by dt, negative rate of change of magnetic flux. Let us divide the two equations, that is equation 1 by equation 2. When we divide, then we will get like this: V1 by V2 is equal to minus N1 d phi by dt by minus N2 d phi by dt. Yes, let us cancel something. D phi minus minus cancel, and d phi by dt will cancel. Then finally what you will get it here, right? We will get the V1 by V2 as N1 by N2. Okay, this equation we write like this also, that is V2 by V1 is equal to N2 by N1. Okay, right. This is equation 3. Now if the transformer is 100% efficiency, in case of ideal transformer, right? In case of ideal transformer, okay, real transformers are not ideal. In case of ideal transformer, okay, that means 100% efficiency. It has 100% efficiency. The input power. Okay, let us continue. In case of ideal transformer, the input power equal to output power. What is input power? Tell me, what is input power? Right? Input power equal to output power. Input power equal to output power. Output power. Okay, right. We write like this: V1 I1 input power equal to output power is output voltage into current, V2 I2 we write. From this we will get V2 by V1 is equal to, we write as I1 by I2 we write. This is equation 4 we write. Okay, and from equation 3 and 4 we write generalized equation, right? You take the screenshot and note every point. I am going to rub the left side. Right, let us see here. From equation 3 and 4 what we write? From equation 3 and equation 4 what we write? left sides are equal, right sides also equal, then we write a generalized equation. V2 by V1 is equal to, we write as N2 by N1, N2 by N1, that, but V2 by V1 equal to I1 by I2, I1 by I2. This is only for ideal transformer, right? This is only for ideal transformer. In case of ideal transformer, this is the formula. And here transformer efficiency, okay, and the real transformers, in that efficiency, how we can calculate efficiency of transformer? Efficiency is the output power by input power, right? Input power, that is the V2 I2 by V1 I1 we write. If you want the percentage of efficiency, its formula is output power by input power into 100 we write. This is nothing but V2 I2 by V1 I1 into 100. This is the percentage of efficiency, okay, right? And from equation 2, from equation 3 we write one thing. From equation 3, what do you know from equation 3? Right, V2 by V1 is equal to N2 by N1 we write. From this, V2 is equal, we write N2 by N1 into V1. This N2 by N1 is called as transformer ratio, number of turns in secondary coil to the primary coil. This ratio is called as transformer ratio. If N2 greater than N1, number of turns in the secondary coil is greater than the primary coil. If N2 greater than N1, then V2 greater than V1 we will get. Output voltage is more than input voltage. This transformer is called a step-up transformer because it is increasing the voltage. Step-up transformer. And then if N2 less than N1, right, then V2 less than V1, this is called as step-down transformer. Now there are several losses are there. Why the real transformers are not having the 100% efficiency? Okay, input, how much power you will give, how much energy you will give, that much energy you will not get in the output. In case of transformer, there is a loss of energy is there. Why it occurs? Okay, how we can reduce them? Loss of energy in transformers, loss of power or energy in transformers. How they will lose the energy or the power in transformer? Okay, the reasons. The first reason is that, okay, copper loss we write. Copper loss. Okay, copper loss. This is the first reason. This is due to the resistance of wire. Resistance of copper wire. We are winding the copper wire at here. This is the first loss, that is the copper loss. The copper loss is to be that is due to the resistance of the copper wire. Okay, transformer is made with the copper wire is wound on both sides in the primary coil and secondary coil. Due to that, when the current passes through that, some heat will be developed at that heat will be develops. Due to that, some loss will occur, that is called as the copper loss. That is the energy losses in the form of heat. That is the heat energy is equal to I square RT, right? And then it can be reduced. by using thick wires, by using thick copper wires, thick copper wires. What happening at here, when the current passes through the winding copper wire, at that moment some heat losses, some energy losses in the form of heat. Okay, right, that is the copper loss. And the second one is the second one, what type of loss will be there, that is the second one is the iron loss. Iron loss. What is this iron loss? Actually the copper wire wound, okay, the coil or the copper wire or coil is wound over the soft iron. Okay, soft iron. When current passes, what happens when alternating current passes through the copper wire, okay, what happening, current changes, with that field changes, that change in field, change in flux link with the soft iron, in that eddy currents generates. Okay, eddy currents generates in soft iron. Eddy currents generates in soft iron. This eddy currents, okay, due to that it loss of heat will be occurs. Eddy currents generates in soft iron. Due to that energy loss in the form of heat. Energy loss in the form of heat. How it can be reduced? How it can be reduced? It can be reduced. It can be reduced by laminating the soft iron plates. Okay, right, that core is laminated. Laminated means it is coated with some paint. Okay, this is second one. Next I am going to rub the board and you take the screenshot and note it. Okay, let us see here. The third one is what? This is the resistance of copper wire or winding. This is only winding, right? What I want, the third type of, there are 4 types of losses are there, energy losses. That's why the real transformers are not having the 100% efficiency. Input power is not equal to output power. Let us see what is this. The third one is hysteresis loss. Hysteresis loss. What is this hysteresis loss and how it can be reduced? Okay, and hysteresis loss means when the current passes through the coil, that soft iron, the coil is wound over a soft iron, that soft iron is magnetized, but the current is changes and its direction also changes. That's why the soft iron core magnetize and demagnetize. And then again magnetize. Soft iron core magnetize and demagnetize continuously. Due to that energy losses in the form of heat. Energy loss in the form of heat. Then how to reduce it? It can be reduced. It can be reduced by selecting a material, for core. Okay, which type of material we have to select? By selecting a material or the core with less area of hysteresis loop. Hysteresis loop or less hysteresis loss. Okay, and the next fourth and the last one is the flux leakage. The last one is the flux leakage. What is this flux leakage? Due to the flux leakage also, and the input is not equal to output. What is this flux leakage? Actually, the change in flux generated in the primary coil, that will be linked with the secondary coil. Then in that moment it should be passes through the air. The loss of flux occurs in air, right? Loss of flux occurs due to the air gaps. Loss of flux occurs means how much flux generating in the primary coil, that will not link with the secondary coil. When the flux link changes, at the moment the output voltage also changes. Loss of flux occurs due to gaps in soft iron plates. Okay, the flux link with the secondary coil not equal to the primary coil. It can be reduced. If the two coils are wound like this. For example, this is a coil, like this it is there. The primary coil wound like this, the secondary coil also wound over the primary coil. This is the input voltage and this is the output voltage. In this case, right, it can be reduced by wounding secondary coil over the primary coil, right? Primary coil. This is about losses and how they can rectify. This is very important. Thank you for watching my lecture.